Well, I'm Rasoul Sadeghi, PhD student in the cycle 35. So my presentation title is Wide Bandwidth Multi-Layer Orchestration of Optical Networks. So let's go to the introduction part. All of us know that the network traffic is increasing over the year, and so the operators need to increase the capacity of their networks that today works in 4.8 terahertz in only C-band. So for this reason, elastic optical networks plays an important role, and also traffic grooming is important, and simultaneously using decreasing the overall power consumption in the network with increasing the capacity is more important. So in order to this, the latest implementation agreement is the 400ZR that is defined as a power efficient and cost effective coherent interface that supports 400G with a symbol rate of 59.84 gigabaud. So as I said already, we need to increase the capacity of the network. So operators have two main options to increase their capacity. The first of it is upgrade their line system to support C plus L plus S band, or make use of regenerator to increase the capacity of their network. So, and a brief overview of my work, I have to say that the first result that I have done is performance comparison of translucent C-band and transparency plus L-band network. At this work, we compare transparent and translucent network design in terms of capacity and energy consumption, and also the cost. So in here, results show that when we go to the multi-band enabling the L-band parallel with the C-band, the capacity increased 2.35 times. But when we put regenerator signal regeneration in our networks and remain in the single band, we see that the capacity increase only 25%. So the strategy that we use for regenerator assignment in our work is like that. If you consider the node A as a transceiver and node D as a receiver, we see that our algorithm continuously check the light path and then assign the regenerators. That in here, at this example, the only one regenerator assigned in the node C. So this we consider two important things. The first one is that the same modulation formats for the end-to-end connection we consider, which means we did not change any wavelengths in any modulation format before and after regenerators. And also we did not consider the wavelength conversion in before and after the regenerator assignment. And also regenerator placement algorithm deploys the regenerators only when needed, avoid unnecessary increase of cost and power consumptions. In viewpoint of the power consumption, we see that the multi-band approach use 4 dB less power in comparison to the translucent case in a single band. And also another investigation that we have done, we added the power consumption of the amplifiers in different bands that we see in here, that the overall power consumption did not change a lot, and 4 dB remained the power consumptions in the C-band translucent case. And the final results that I have to show to you is that we use this algorithm in order to regenerate assignment for the poor quality of transmission bands such as S-band that we published in ECOC. As you see, when we go for the adding the regenerator signal regeneration in the S-band, we see that the capacity increased 13 terabit per second without any limitation in the S-band to the capacity of the light path. And overall view of my this year achievement, I have to say that I could publish six papers as a co-author and 7 first other accepted papers. And also now I'm going to write a journal paper for JLT, a special issue with it, which the deadline is 30th of November. And also I will collaborate with 2 of my colleagues in another, one in another country and one in our Polito, to publish 2 journal paper. And also I'm working in my works to publish, to submit a paper for the OFC 2022 of this year. So as a conclusion of my work that I showed in here, I presented. I have to say that the utilization of regenerator to enable higher modulation formats has a limited impact in capacity increasing, while augmenting cost and power consumptions, and also exploiting the C plus L band and flexible transceiver is shown to be more effective in our work. So finally, I want to thank for your attention. If you have any question, you can send me email or ask. Thank you.